Here's another lecture. I've also updated the schedule a bit for the rest of the semester. Normally after week 7, let's go over to the schedule. So normally after week 7, we'd kind of talk in class about what we want to cover next as a class, because there's some different options and directions that we can take the class in after we've covered most of the basics. Obviously we can't do that this semester. Based on the poll, it seemed like you guys were interested in doing 3D graphics. And so I think that can be a fun thing to do for a couple weeks. So I have a couple lectures that I'm going to do around doing 3D graphics, and then I also want to cover sound for a week, just so that you guys have the option of adding sound in your final projects, because that can be very useful for kind of rounding out a multimedia project. So then that'll take us through week 10. After that, for week 11, we're going to do just working on a final project pitch. So you guys can, I'll make a little demo for how to do that when we get there. But you guys can take a look at the final project pitch and start thinking about what you might want to do. Then we'll have a couple weeks to work on the final projects, weeks 12 through 14. Since we're not going to be meeting in class, we'll have one-on-one meetings. I also want you guys to turn in a work in progress site each week, and then the final project will be due in week 15. So if you have any questions about that, just email me or reach out to me on Discord. So I'm going to get into some 3D graphics stuff now. So when you think about 3D graphics, you might think about something like this, like a 3D animated film. And that is definitely, a good example of 3D graphics or CGI. Obviously, very complex animation that's happening. So we're not going to do anything quite at this level, but we'll see some of the basics of how this works. But you usually associate 3D graphics with like a high-budget film or video game or something like that, and not really with a website or a simple project. But there's been a lot of changes and advances in 3D rendering for the web. Some good examples of 3D projects on the web you can find on the 3JS website. So 3JS is a 3D rendering software. It's a bit more complex than P5, so we're going to stick with P5 for now, but they work with a lot of the same ideas. The 3JS website is a good place to kind of see some examples of what you can do with 3D on the web. So pretty simple graphics, pretty simple animations. So, it's not super complex. There's a lot of stuff going on, so it would take a long time to build a project like that. But you'll see some of the stuff in what we're going to look at today. This is kind of a nice interactive animation. So we have some basic 3D objects. We can put them together to trigger a new animation. So this is made from some pretty simple 3D shapes, so that's something that you could try to recreate in your homeworks. And this project is one of my favorites. It's a little online 3D dance party. So we have a few different animations, and we can change some of the parameters in the animations. And then we can scroll around in 3D space. So that's kind of just a fun one. This one is just like a simple logo. It's just like an interactive object on a website. Doesn't really have anything else to do with 3D rendering, but it's just kind of a fun interactive logo. So yeah, those are just a few interesting examples of stuff that you can do with 3D graphics on the web, where you can combine some 3D rendering with some of our user interactions that we've been looking at throughout the semester. So let's go into it and look at some of the basics. So I'm going to start a new project. And as usual, when I start a new project, I'm going to start by opening up the GitHub app. I'm going to make sure I'm on my 310 repository, make sure I'm up to date. And then I can open up my project in Sublime Text from here if I want to do that. I can also, drag it into my Sublime window, Sublime icon here. And then I'm going to also show in Finder so I can make a copy of the project to get started. So we're going to start a new project. I'm going to just create a new folder and call this 3D. And so we'll start from there. I'm going to grab a few files. So I'm just going to get the index.html. I'm going to copy that and paste it in, and then get p5.min.js, just make a copy of that, throw it in there, and then the style.css. So just our kind of basic setup. So we can start with a website, and then I'll go over to Sublime. In Sublime, I'm going to open up the main index.html for my, and here I'm just going to add a new link. So under the user interface link, I'll just add a new list item, anchor tag, href. For this one is 3D, and I'll say this is the 3D example. So I'm going to do two different demos. One is just a basic example covering some basics and setting up like a little starter scene for you guys, and then I'll do more of a demo of like creating a composition, which will be more similar to the homework. So I'll do that in the next video. So once I've got that link, I'm just going to go to Tools, Sublime Server, Start Sublime Server, and now I can go back to Google Chrome and just open a new window, and I will go to localhost 8080, and so there's my Sublime server, and I'm just going to click on MMP 310 and go to 3D example. So nothing there yet. We're going to add some stuff, so I'll just open up the console so I have that ready. Make this a bit bigger. And then I'm going to use a lot of references from the P5 website, so I'm just going to have that open to begin with. Making 3D graphics is a little bit more complicated than doing 2D graphics, so we're going to be using the P5 reference a lot. We're going to be looking at the shape area where we'll be looking at the 3D primitives, the lights. We're not going to do camera today, we'll just look at lights. And then we're also going to be reviewing transforms. So you probably talked a bit about transformation in MMP 210. We're going to review a little bit about how that works in the context of 3D because we need to use it more with 3D. So we'll get to that in a bit. We're just going to start simple by setting up a scene and looking at some of the basic shapes. So I'm just going to click shape, and so we can see the 3D primitives here. Kind of similar to our 2D shapes like the rectangle and the ellipse and what we're used to, but we have some new 3D primitives that take into account the 3D environment. So as we start to add those into the scene, I'll try to go over what makes 3D different from 2D. So I'm going to go back to Sublime, go to my 3D folder, open up index.html. I'm just going to change this title to 3D example, just so I know where I'm at. And then that's all I need to change there. So I'm just going to close this and make a new file for my sketch and save as. Go to the 3D folder and save this as sketch.js. Whoops. And now we're ready to get started. So I'll get started with a new sketch. As usual, I'm going to add in a comment. So I'll just say 3D graphics example. And this is April 5th. So I'm just going to start with a setup. So I have function setup. And most of this will look similar to what we've seen before. I'm going to do create canvas. And I'm going to do window width and window height. So it'll fill up the whole window. But when I'm doing 3D graphics, I have to add in a third argument here to tell the canvas to be rendering in 3D, and that's just WebGL. WebGL is just the name of the 3D graphics rendering language in the canvas. So if I just put WebGL there, then it knows that it's going to be doing some 3D graphics. So there's my setup. And let's just make a simple scene, and then I'll talk a little bit about what we're looking at. So I'm going to do function draw. I can still do a background for this one, so I'm going to do kind of a dark background because we'll be working with lighting eventually. So I'll do background as 51. And we're just going to start with some simple geometry. So if we look at our 3D primitives right here, we can start with the plane. And the plane is actually basically a 2D shape. It's just X and Y, but we're rendering it in 3D. So I'm going to just draw a plane. I'll do like 100 pixels wide and 100 pixels high. And then let's take a look at that scene. So there's our plane right there. It's a little small, so we can make it bigger. Make it 200 pixels by 200. And so right now we are looking directly at the plane, which is why we see what essentially looks like a rectangle, or just a 2D shape. And what we're going to do now is add some controls in order to rotate the plane in 3D space. And once we have those, I'll talk a little bit more about the perspective. So these are just some basic controls I'm going to add so that the user or the developer can rotate the object that we're creating. And so that way we can actually see the depth of the 3D environment. So this is something that you won't have to recreate. You can just copy and paste this in your own sketch. And I'll have a template for this that you can look at. So this will just make it a little bit easier to work on our 3D graphics. So I'm going to use some sliders. We worked on the interface last week, so that's a nice kind of introduction to this. So I'm just going to add 3 sliders to control the interface. So I'm just going to declare them in the global scope as I normally would. So I'm just going to call these control rotation. And so we need to rotate not just on the X and Y axis, but also on the Z axis. So I'm going to make 3 variables for one for each of the sliders. So rotation on X, rotation on Y, and rotation on Z. And I'm going to create these sliders inside the setup function, just at the start to add the sliders into the scene. So I'll make a little label for them first so we know what they are. So I'm just going to say create P for paragraph, and I'll just say scene control. And then I'm just going to move these. I'm just going to add position directly at the end of this. So I'm going to say position is like 1010. And so that should add that little label into the scene. We can see it up here. It's hard to read, so let's change a couple things. I'll just do this in style.css. So I'll just change the color of text to white. And let's change the font family to something more readable. I'll just say monospace. And let's just make it a little bit bigger. So let's say font size is 18 pixels. Okay, so that's a lot more visible. I'm also gonna, this is like a paragraph. So I'm gonna get rid of those margins. We don't really need those, so I'm just gonna say P, and then margin is 0. Okay, so we've got our scene controls labeled. Let's add them in. So we're just going to take rotation X, and we're going to make a slider. So I'll say create slider. And so from last week, you should remember that the input for the slider is the starting value, or the minimum value, the maximum value. So we want to be able to rotate a lot in both directions so we can really see everything in the scene. So I'm going to do -2 pi for the minimum value and 2 pi for the maximum value. So 2 full rotations in each direction. So just a quick reminder, when we're dealing with rotation, we are talking about units in terms of pi. So 1 pi is basically half a rotation. So if we're rotating around an axis, that's 1 pi, which is equal to like 3.4 something something something, and then 2 pi is a full rotation. So the numbers that we're working with for rotation are in terms of pi, so they're actually relatively small numbers compared to our pixel measurements. So let's just put the rotation x a little bit below the scene controls. I'll actually put 0 for the y value on the scene controls. Oops. So there's our x control. So we have the slider, so let's actually connect that to the rotation in the scene. And I'm going to go a bit fast here just because you guys will just be able to copy and paste this code. You don't need to recreate it. So we start with the rotation, and this is actually where our transform stuff comes into it. So if we look back at the reference and go to transform, we have rotate. You may have used that in MMP 210. Translate, you probably also used. There's also rotate X, Y, and Z. So we're going to be using all three of those in the example today. So let's start with the X rotation, and we're just going to be using this to rotate our scene just so we can see what it looks like. So I'm going to rotate X, and I'm going to put in there the rotation X slider dot value. So whatever the current value of the slider is. And we'll see that's actually going to rotate our plane. And so there's a couple of things here to note. So to start, the rotation is happening on the x-axis. So remember that the x-axis goes across the screen. Here's the x-axis. And so when we rotate around the x-axis, it actually looks like we're moving forwards or backwards. So it kind of looks like the plane is rotating towards us. That's because we're not rotating along the x-axis like that. We're rotating around the x-axis. So that's why we get that rotation. And so now we can start to see the actual 3D space. So with this 2D plane, we can see some perspective. So if we rotate it to a certain point, because it's a 2D plane, it just becomes a line. It doesn't have any 3D shape to it. But if we look at it at different angles, we see in some angles it looks like it's moving backwards or moving forwards because of the perspective. So let's add in the rest of our rotations, and then we'll talk a bit more about how that works. So for this one, I'm just going to copy and paste these lines because they're pretty much exactly the same. One thing you probably also notice with this control is that it moves in pretty large chunks. It doesn't kind of like smoothly rotate in between, and that's because the default increment for our slider is 1. And since we're measuring our rotations in pi, we're basically like doing a full rotation, just 1, 2, 3. So we want to get that to be a little bit smoother, so we can add extra arguments to our slider. So we'll start with 0. 0 is where it starts out to beginning. So we have the min, the max, and where it starts. And so this is 0 rotation. It actually looks a little bit rotated, but I think we can fix that. So then we can set the step or the increment, how far it rotates when we move it. So what we're going to do is just take pi and divide that value, what we'll do is take 2 pi, so 1 full rotation, and then we'll divide that value by 360, which is how we normally think about rotation in terms of degrees, a 360 degree rotation. So now our rotation will be much smoother because we're getting a finer degree of change in between each step. Okay, so let's add the rest of our sliders, and then we'll talk a bit more about the 3D geometry. So I'm just going to copy and paste these two lines because the rotation X, Y, and Z pretty much work the same way, but just on different axes. So we'll do Y there and do Z here. And then I'll just move these guys down a bit. So we'll go 20 and 40 and 60. So we've got our 3 sliders. Now I'm going to copy this one and paste a couple times. So we'll have X, Y, and Z. And so now I'll be able to rotate on the X, the Y axis, and the Z axis. So let's talk about why those rotations happen the way they do. So what we're used to with P5 is we've got X going across the screen horizontally, and we've got Y going down the screen vertically, and everything that we look at is positioned in this 2D plane. And so we don't really have to worry about things like how far is the user from the screen or how close, because everything is just represented in 2D. So, if we want to move something to the right, we just do that. If we want to move something to the left, if we want to make something appear bigger, we can just draw it bigger, or smaller, we just draw it smaller. But in 3D, we have perspective. So we don't just have a 2D space that always looks the same. What we have instead is a viewer, which in 3D we usually refer to as the camera. So we have, if we look at it from a top-down perspective, we have like a camera, and it's looking at our scene. And so if we have like a cube right here, then what determines the size of the cube is how close the cube is to the camera, the Z. And then the X is, still horizontal, and the Y is still vertical, but it happens in a different direction. So we can also think about it, we have X here, we have Y here, and then Z is coming towards us. So X is positive and negative, Y is positive and negative, and then Z is positive as it comes away from the screen and towards the viewer, and negative as it goes into the screen or away from the viewer. And so our code for the graphics rendering is actually doing all that calculation for us to determine, if we're drawing something in perspective, if it's moving away from us, then it'll be bigger in the front and smaller in the back. And so we can kind of create this idea of perspective with our 3D graphics just by kind of changing the rotation or doing other things. So with 3D, we don't just think about where something is in terms of the 2D space, but also where it is in terms of its depth or its how far away it is from the viewer. And so when we think about rotation, it looks a little bit different, because when we rotate across the x-axis, as we saw, we're really rotating around this axis, which looks like it's moving towards us or away from us. And with y, we're going down this axis, so it's going around like this. So that's the y rotation. And then finally, the z rotation is actually coming towards us. So we can't really draw this axis because it's actually pointing directly at us and away from us. And so when we rotate around that axis, then we actually see more of a 2D rotation that we've seen before, but that's around the z-axis. And so those scene controls are really there just to help us kind of see our geometries, our lighting, and different things like that. So we're going to move on now to, we'll move on to the other shapes. I'm going to leave this plane here. I'm just going to make this like a floor to orient us. And it'll also point out another thing, which is that if we move this rotation below the plane, it'll no longer affect the plane. So it's sort of like a fill or a stroke or other things in P5. If the plane happens before the rotation, then the rotation won't affect the plane. If we do have like a box down here, so we'll do the box geometry next. Now we'll be able to rotate this box, but the plane will stay in the same place. So we can move this rotate stuff to only rotate the scene that we want to. So I'm just going to turn this plane into a floor real quick. So I'll move it down on the y-axis. And so to actually move our geometry, you can see that the plane has an x value, or has a, so to move our geometry, we actually need to add a translate function. The plane has a width and a height, but we can see in the reference for the plane, there's no option for x or y. Detail x or y refers to the amount of detail in the geometry, but we can't actually change the position of the plane just through this geometry. We have to use the translate function to translate the whole canvas, so it's a little bit more complicated. So if I want to move this plane down to be a floor, I'm going to have to translate first. So I'm going to say translate I'm going to stay at 0x, and I'm going to move down maybe 200 on the y. And so the box actually moved with me. So that brings up another issue, which is that we don't really want this translation to apply to this box. And we don't want to have to come down here and then say something like translate 0, negative 200, just to undo that translation. So what we can do is use our push and pop function. So that's something that we haven't looked at much this semester, but you probably covered in MMP 210. What we can do with push and pop is we can save the original translation by pushing, and then we can translate and then pop. So that takes us back to the original translation before we pushed. So that means that the box does not have this translate applied to it. So now our box is up in the 0, 0 position, and we can move the scene, but our plane can move down. So let's actually move it down a little bit further, and then I'm going to rotate on the x-axis to move the plane into a horizontal position so that it'll look like a floor. So I'm going to say rotate x, and I think I want to rotate like half pi, so I'm going to say pi times 0.5. Okay, so that looks a bit complicated, but really all I'm doing is I wanted to rotate, the plane was like this, and I wanted to rotate it down to be a floor. So we've imagined that here's the viewer or our camera, and this was our plane in its original state. We want it to rotate down a bit so that it'll look like a floor, which is what we see here. And so we know a full rotation is pi. So a half rotation, which is what we want here, is pi divided by 2 or times 0.5. So I'm using 0.5 just because it'll be easier to change that value if we want to. So that's how we get the rotation there. And let's make it a little bigger so it covers a bit more space. So we have like a nice little floor, and that'll kind of orient our scene. I'm going to make it even a bit bigger than that. Okay, so that'll kind of give us some orientation in the scene so that even as we're rotating our object, we'll still know sort of, where the bottom of the scene is. All right, so let's move on to our box geometry. So we have a box. It's basically just a cube. It's pretty simple. We can rotate it and move it around. So that's pretty straightforward. If we just have 100 there, it applies to each dimension, x, y, and z on the box. If we add another value here, we can change the height. So now we have a box that's a bit taller. So let's look at the box. So we have width, height, and depth. So we can change z as well. If I make it like 50 on the z, then we'll see that it's very skinny compared to how tall and how wide it is. So let's add another shape to the scene. The next one we can look at is, let's look at the sphere. So a sphere is like a 3D circle. It's just a round object like a ball. And so like the box, the first value for the sphere is going to be the width or height. And it'll just be the same on all sides. And you can kind of see that the box and the sphere are overlapping. So again, we can't change the position of the sphere or the box. So if we want to move the sphere somewhere else so that we can see both geometries, we can translate before we draw the sphere. And I'm going to draw other shapes. So I'm just going to go ahead and push and pop because I know that I'm going to want to move my other shapes around. So the box doesn't need a push and pop. It's just at 0, 0. But if we're going to add a translation, then we need to push and pop. So I'm going to translate. I'm just going to move over 200 on x, 0, 0 on y and z. And so now we have a sphere next to our box. And if we rotate, we can kind of see the relationship in space between the two objects. Stays consistent. So that's how we can translate and add other shapes. So let's keep going. So besides the sphere, we have a cylinder. A cylinder is basically just a circle with a 3D width. So let's do a pop and let's add a cylinder. So we can just say cylinder. We'll start on the cylinder with the radius. and then the height. So for the radius, let's say it's 50. For the height, we can say, actually, let's do the opposite of our box. So let's do 100 for the width, for the radius, and 50 for the height. And so there we can kind of see our cylinder. It looks like a wheel, essentially. And we can leave that where it is. It looks kind of nice. If we wanted to like make some kind of cool shape out of that, maybe I would move it up or down on the box so I could still do a translate. So I could say push, translate. Maybe I'll move it a bit up on the Y and pop. Okay, so that's kind of it. You know, we can start to combine our shapes that way. The detail for the sphere and the cylinder does kind of matter, so we can review that real quick. So the cylinder, we have the detail X and detail Y. That basically just determines the number of geometries. And so you can see these geometries being represented here with these lines. And the more of those lines you have, the more detail there is in your shape. If we remove a lot of that detail, we'll see you kind of destroy the shape. So if I do 1 and 1, so now the detail is very small, and we don't actually have a cylinder anymore. What we have is like kind of a triangle with some depth. So that's not really a cylinder, although you could use that as a shape. So if you wanted to make a triangle, a cylinder is a good place to start. If we change that to 2 and 2, now we just kind of have like a more complicated triangle. So when we get to 4 and 4, we're going to see a little bit more detail. This is just kind of another box, diamond shape. Now when we get up to 8, now we'll start to see a little bit of curve, but we actually have more detail than we need in the sides, so we can get rid of the detail Y. You really don't need much detail on the Y for a cylinder, so we can leave that at 1. And so now we're getting a lot more detail in the cylinder. If we go up to 16, that's a ton of detail. I'm going up in powers of 2. You don't have to do that, but that's what we tend to do when dealing with graphics because it's easier for the computer to deal with. So then let's go up to 32, which I think is the default. Oh, actually, it says I can't do more than 24. So let's try 24. Okay, so 24 must be the default. So we can see the detail working with our cylinder. We also have the detail on the sphere. So I forgot to do that. Let's go back and look at that. So here's the sphere. There's the width. And then we go to detail. So if we do 1 and 1 on the sphere, we're going to get a similar thing where it just kind of destroys the geometry. It's literally just a line. If we go to 2 and 1, now we see more. No, it's still just a line. What if we do 2 and 2? Okay, so now it's kind of it's a plane that's just rotated. So if we go to 4 and 4, okay, now you start to see the shape of the sphere. So again, that's kind of interesting. You might want to use that, but if you want a round looking surface, you need to add more detail. So maybe we could do 30, oops. Or actually, I guess 24 is going to be the limit. No, there's got to be more than that. Nope. Okay, so there's 24 detail, and that is in the X. So you can see there's more detail going around than going up to down. So then if we up the detail on the Y, that's when we get back to our regular sphere. So we can see that we can actually get more geometries than what we start with. So let's look at the cone. Well, actually, I'm going to use the cone in my demo, so I'm going to skip that one for now. I'm also going to use the ellipsoid. The torus I'm going to use as well, but I'll show this again because we can just add another shape here. So I'm going to push again. I'm going to translate to the other side of my box. So I'll go like -200, 0, 0. And I'm just going to draw a torus. So if we start with just 100, the torus is like a kind of a donut. It's like a cylinder that wraps around itself. So there's our torus. You can see the 100 pixels is kind of the width there. If we add another one here, that determines the size of the cylinder itself. So if we match the size to the width, you're going to see there's a very small hole. Okay, so that really looks like a donut. But if we have a very small cylinder, then you can see the width of this cylinder is very small. So that's how we can kind of control the look of the torus. The default looks like it's actually about 10. So that's kind of interesting. So yeah, there's our torus. So those are some of our basic shapes. The torus also has some details. So if we add that in there, so if we add maybe 20 for the width, and then we start to add detail, maybe do 4 and 4, then you'll start to see, well, there's a torus with not a lot of detail that looks more like a square. Or if we do 2 and 2, that's just a line. If we do 3 and 3, then we get a triangle. And so it kind of goes up from there. So you can kind of get some interesting geometries just with that basic torus idea. There's a pentagram, so we can keep going, 8 and 8. Okay, and then the default, I guess, is probably 24 as well. Actually, I guess the default must be 16. Yeah. So yeah, those are some basic shapes. So we'll look at a bit more of that stuff when we do the demo. We're going to switch gears a bit here now and look at lighting. So right now our shapes just look black and white. It's not very interesting. And we can change the color of the shapes. If we're not using any lights, we can add fill. And that will just kind of act the same way that it would in any other P5 scene. So for example, I'll just add a fill at the bottom here. So if I say fill is like 255, 0, 255, that'll give us like a pink fill. Okay. And so that's not affected by lights, so it's just kind of one main color. But doing 3D, we can do kind of more interesting stuff with the color. We can also do stroke here. The stroke default is black, which you can see. If I change it to white, then we'll get a different look. So this might be an aesthetic that you like, and you can stick with this. But normally with 3D, one of the advantages we have of the 3D space is we can calculate depth, and we can calculate lighting from depth. So I'm actually going to get rid of those. And I'm just going to scroll up here to the top of the program. And just as a default, I'm just going to turn on the lights. So I'm just going to type lights, and that'll apply some default lights to the scene. I'm going to turn on no stroke to get rid of those lines. And now we can see a scene with some lighting applied. So the default lights are pretty simple. We don't see a lot of difference in the shading, but you can start to see kind of the volume and how light applies to different parts of the volume. So we can start to add lights of our own that have different properties, like color, and intensity and position and things like that. So let's go back to the P5 reference and go to the camera lights camera section and just take a look at some of the basic lights we have. So we can start with the ambient light. An ambient light is basically just a light that applies evenly across the whole scene. So I'm going to turn off the lights real quick. So that's our scene without any lighting at all. Everything's just white. And let's add an ambient light. So if I add an ambient light source, this type of light, ambient light, doesn't have a direction. So it just applies evenly to all surfaces. So let me put a note here. And so if we put a color in here, like if I put a very dark color, everything's going to be black. If I put a very bright color, everything's going to be white. And if I put, a color like with a hue, like maybe I'll put a little bit of red, a little bit of green, and maybe a bit more blue, then we get this kind of darker blue color. Let's bring these up a little bit so it's not quite so blue. Okay, so we have this kind of slightly blue color. I might bring those up even a bit more. Okay, so we just have a little bit of a blue tint. So an ambient color or an ambient light is kind of nice just to add a little bit of lighting to the scene, just to make sure your geometry get lost if you have very stark contrast in the rest of your lighting. But the ambient light doesn't really reveal the geometries the way a regular light will. So we'll add that next. So let's add in a directional light. And a directional light acts in the way that it sounds like, and how, a lot of lights behave in real life, in that they have a direction. They're pointing in a specific direction. So our directional light has a color again. So if we make this one like 255, 255, 255, that'll be white. And then we need to set the direction. So the directional light uses a scale from -1 to 1 on each axis to determine where it is. So direction is -1 to 1. And so if we put like 0, 0, 0, that means the direction is just kind of in the middle, so you don't see any light at all. If we move it, like, let's start with x. If we move x direction to 1, so now we can see, and the x-axis 1 is over here, and so the light is going in that direction, which is why the surfaces pointing away from the direction of the light are actually the ones that are lit up. So if the light is going this way, then we see the lit surfaces over here. So you can see light is actually a calculation that takes into account all the lights in the scene as well as the color of the objects. So the default color of our objects is white. So that's part of the calculation for the white, is our RGB value for each object. So right now that's just 255 for each. Then our directional light over here has its own RGB value. So that's also 255 for each. And then our ambient light has its RGB value, which is applied everywhere. So that's another RGB, which is our 35, 35, and 50, which is the kind of blue that we see on the right side. And so when we're calculating, when the scene is calculating the lights, it basically multiplies these color numbers by each other. But when it comes to the directional light, it adds in this sort of directionality. So if the surface, like the one right here, is completely facing that direction, then it's going to be more white, versus this surface over here, which is completely blocked by the rest of the geometry. So that doesn't receive any of this color. So it basically does its own math, and we can just set the colors and not have to worry about the math. So then with that 1, if we change that to a -1, we switch directions. Okay, if we do 1 on the y-axis, then for y, 1 is down here, and -1 is up here. So now we're pointing this way on x, or we're pointing this way on x and this way on y, so that adds up to this direction that we can see right there in the sphere. And we'll see that as we kind of rotate around. And we can also go on the z-axis. So if I go 1 on z, 1 on the z-axis is in front towards us, and -1 is in back. So when we do 1, it's actually pointing towards us, which is why the light appears to be behind the objects. So that's an effect that you might like. If we do -1, which is maybe more often the case, then the light will be coming from the front of the objects, so they're a little bit more lit in this direction. Our directional light can also, we can add a little color. So if I wanted to emphasize maybe the red on this one, I could bring down the green and the blue a bit. So I'm just lowering those numbers, so we just get a little bit of red. I can bring that down more if I want. So now you can kind of see it's a little bit pink. And so now you can really see the difference between the directional light, which is really going to be in your scene more like a sunlight because it's applied so evenly. And then you see the dark side, which is just receiving the ambient light. So you could actually reverse those colors. You could see like the darker side is brighter. But if you want to get a realistic light tone, this is a good way to start. So those are directional lights. And again, we have a direction, but the next light we'll look at is the point light. And the point light has a color, but it also has a position. So instead of a direction, we can position the light in the scene. There's also a spotlight, which has both a direction and a position, so it gets a little more complicated. I'm going to skip that one for today because I think we have enough to work with. So I'm going to open up the point light. And so basically we have a color, just like our other lights, and then the location in the scene. So we have X, Y, and Z in the scene. And this example comes with this nice little code to move the light around. So I'm going to use this as well. So our positional light, or point light, starts with a color. Let's make this one very bright so it'll be very obvious to see. So I'll do full white. And then for the default position, I'll just do 0, 0, 0. And I'll move it a little bit forward on the Z axis like they have in the example. Might need it to move it farther forward to accommodate our geometry. So yeah, you can see the point light right here. It's kind of like inside of this geometry. So let's move that a bit forward. You can see it's applying to the sides of the sphere and the torus, but not the other geometry. So let's move it even a bit further on the Z. And it's still kind of stuck in that cylinder. So let's bring it a bit further. Okay, there we go. So now we can see the point light applying. And you can see it's very bright here. And then there's this like very intense fall off from the point light. So let's add in this code to move the X and Y around. So basically what we're just saying here is mouse X, but then we're centering it. So we're just going to say minus width over 2. And then mouse Y minus height over 2. So you don't need to have this in your scene, but it is kind of nice to be able to move the lighting around a bit to see how the geometry reacts. And so that's our lighting. There's a bit more we can do with that, but we're getting some nice effects here. So I think we'll leave this the way it is, and you guys can play around with that as you're working. The last thing that I want to cover in this video is the material. So we talked about the lighting, how we kind of multiply the color of the light by the color on the surface of our shapes. Right now, all our shapes are a default white color. So when we have a lot of light, it's white, and when we don't, it's dark. But we can actually change the color of the shapes, which will be a lot more useful when we start to actually create a composition to make differences between our different shapes. So let's just look at a few basic materials. And the materials apply in the same way that our basic fill and stroke apply. So I could do a fill here if I said like the fill is plum. You'll see that the lights still actually apply, and we have this, plum color applied to everything that comes after the fill. And another thing to keep in mind is that the push and pop also applied to the color. So if I push the fill in there, see it's now only applying to the plane, my floor, because it's getting taken out by this pop, just like the rotation and the translation. So if we want it to apply to everything, we would put it up here. So a fill will still work in 3D, but the material version of the fill is an ambient material. So let's look at the reference for that. So an ambient material basically just takes a color value and it applies that color evenly. So we can change fill to ambient material. But we can't use plum here. We have to give it an RGB value. So I'm just going to look up HTML color codes and look up my plum color. Okay, there it is, 221, 160, 221. So I'll put that in as my red, 221, 160 for green, and 221 for blue. So we still have that plum, so that looks good. So that's the ambient material. It just kind of applies evenly to everything. If I don't want that to apply to my floor, I can just move it below the floor. Well, actually, it's still applying to the floor because we're coming back around. So I would just have to do a white ambient material to unset that. Okay, so now we have the floor is back to white. So now we have this ambient material applying to everything below it. So the ambient material still accepts lights and it still does that calculation, but it looks very dull. It's sort of like a dull surface, like maybe a piece of cloth, or it kind of looks like a clay or something like that. If we want to do a different type of surface, we can use a specular material which reflects light and might look like something shiny, like a piece of plastic. So let's leave the box, and since the cylinder is kind of the part of the box, I'm going to move this part up here, and let's apply something different. So let's apply a specular material to the sphere and the torus, and we can give this a slightly different color. So I'm just going to make it kind of blue. I'll say 200, 200, 255. So it's going to be a light blue color. And you can see the shininess or the light on the specular material is much brighter than on our ambient material. So it's reflective, like a glass surface or a piece of plastic or something like that. We can change the shininess a bit with the shininess function. So if the shininess is like 0, it's going to be there's going to be a very stark contrast between the light part of the surface and the darker part of the surface. If we move this up a bit, then there's more of a fall off. So we kind of see the bright part, and then there's more gradation. And so we get these kind of nicer little highlights here. If we move this up all the way to 255, then you just see some basic highlights on the surface, but nothing too over the top. So I'll probably put this around maybe 150, so it's not too crazy, but we still see, we kind of get that sense of like, here's this kind of like shiny plastic surface versus this more diffuse ambient surface. And that's pretty much all we can really do with our materials in P5. There's a lot more complex stuff that we can do with 3D rendering in other systems, but it's still kind of a new thing for the web and especially for P5. So we'll stop there for now. The next video I do will be a demo where I'm going to make like a little cat character, kind of based on some of the same ideas. So this obviously is not like, it's kind of just an abstract drawing, but for the assignment, what you guys will try to do is create a composition. So, you can think of something that you would want to make, like a character or an object. You could do like a car. You could look at some of the examples on the 3JS website to find some inspiration, and then try to recreate it in the scene. It's a bit time consuming working in 3D, so I don't expect these things to be crazy detailed. But you should try to make something that looks, identifiable. Like it should be obvious what the thing is that you are trying to create. So, start just by looking at these examples and trying to create something. I'm going to post another video on Wednesday where I'll kind of show my process for creating a composition. And so you can give it a try on your own first, and then I'll post another demo that should give a little bit more guidance for that. But if you have any questions, obviously before Wednesday, please reach out to me on email or on Discord, and I'd be happy to kind of help you go over anything.